Now, there are evolutionists who rely heavily upon radiometric dating processes to determine the age of a rock. Now, understand, anytime I use a big word, I always wanted to define what it means. What does the word radiometric mean? Well, it means the use of radioactive materials to supposedly measure the amount of time since an event has occurred or a creature lived. You've all heard of carbon-14. Maybe you've heard of uranium, lead, potassium-argon, rubidium, strontium. There's all kinds of these, but carbon-14, potassium-argon, rubidium, strontium, uranium, lead, those are the ones that most people know of. Actually, there's over 80 of them. And they say that you can date a rock, millions, billions of years old using these radiometric dating processes. However, that's not true. First of all, none of them work. Not one of them works. Carbon-14 doesn't work. Even the man who invented it, Dr. Libby, admitted it didn't work. But none of them work. First of all, none of them work because they all start with 5 false assumptions, and carbon-14 has 7 false assumptions. Now, would you agree with me that if you have a dating technique based on 5 false assumptions or 7 false assumptions, then you're not going to be able to get a reliable date? Is that correct? I mean, that's right. You also have to remember that in the case of carbon-14, that the flood of Noah would drastically change the carbon cycle, so that really throws it off. And then would you agree with me on something? If these things actually worked, if they did, and you could use 2 different methods on the same rock, wouldn't you expect them to be approximately the same date, about the same age and so forth? Is that right? I mean, agreed? If you could use 2 different ones on the same rock, if they work, they should be about the same, right? Okay. How about if I was within 10%? Would that be satisfactory? I'm willing to negotiate. What do you want, 15%? 10s, okay, well, I got 10's enough, okay. Well, good. Well, here's the problem, you see. Not only do these methods not work, there are major contradictions between different dating methods used on the same rock. For example, this is Sunset Crater National Monument. It is south and east of the Grand Canyon in Arizona. It's a relatively small volcano, beautiful though. It gets the name Sunset because the cinders at the top just glow at sunset. Now, anybody who knows anything about Arizona, New Mexico, that part of the United States would know that there's a large number of Indian ruins in this area. As a matter of fact, there are Indian ruins right in the park area. And so let's think. We know that this eruption can be dated at about 900 years ago. We can do that by tree ring countings because 900 is not a big deal. And we know that there were Native American Indians living in the area. First of all, there were remains of their houses and so forth are there. And also, in the cinder cones, in the lava flows from this eruption, we found Native Indian artifacts. So we know that there were people living there at the time that the eruption occurred, and some of their artifacts were trapped in the material from this eruption. So, there were Native Indian artifacts found in the lava flows and cinder cones. Now, this is volcanic rock. Now, when it comes to volcanic rock, the method of choice here would be the Potassium-Argon method of dating. And so we Potassium-Argon dated some of this material, and the laboratory that did the work came up with a date of 210 to 230,000 years old. I think that's more than 10%. Am I right here? Oh. Or what about this rock? This comes from Australia. This is a piece of volcanic rock from an eruption in Australia. Inside the rock, when we cut it open, we found this burned wood. It's really charcoal. So let's think. This volcano erupted. The rock completely surrounded a piece of wood. There's no question there's no contamination here. The rock completely sealed the wood inside. Now, the heat of the lava caused the wood to burn. And so we were left with basically charcoal inside the rock and lava rock on the outside. Now, of course, since this is charcoal, you would use the carbon-14 dating technique. And the rock is volcanic, so you would use the potassium-argon technique. Now, understand, please, I don't agree with these dates. You do understand that. I believe the Earth and the universe are 6,000 years old. However, the laboratories that did the dates got for the carbon-14 date on this wood an age of 45,000 years old. Now, again, I don't agree with it, but that's what they got. The lab that did the potassium-argon date on the piece of lava got a date of 37 million. I think I see a problem here. I think that's more than 10%. Am I right here? Oh. Now, ladies and gentlemen, I'm particularly proud of this particular one, so I want you to take careful attention. Let's go back to year 1801, Hualili, Hawaii, on the big island of Hawaii. Now, you know the Hawaiian Islands are just volcanoes that stick out of the water, right? So I want you to think about this. So the volcanoes of the Hawaiian Islands are just coming up from the ocean floor, sticking out of the water here, 2.6 miles and higher here. But here are these volcanoes in the Hawaiian Islands. Now, in 1801, there was an eruption of one of these volcanoes, and the lava flowed from the top of the mountain, down the side of the mountain, into the ocean water, went all the way down the side of the volcano, all the way down to the ocean floor, 2.6 miles down. Okay? Now, people were there to see this eruption occur in 1801. Now, I'm kind of proud of this, so I want you all to pay close attention to this. Okay, are you ready? Come on, are you ready? Okay. In 1801, there was an eruption. You missed it, didn't you? Come on, I'll show it to you one more time, okay? In 1801, there was an eruption. Now, you're all supposed to say, ooh. See, I'll show you one more time. See, in 1801, there was an eruption. Ooh. There you go. Well, we got the bright idea. Let's send a robot down and test this lava flow for the age using the Potassium-Argon method. So we sent a robot down. It went down 0.8 of a mile, got a 0 million years old. Now, first of all, that is correct, because think with me for a second. It was only 200-year-old material. Potassium-Argon is not good on hundreds, thousands, hundreds of thousands. It's only good on millions. And so if this material is only 200 years old, then 0 million is correct. Everybody with me here? We got the bright idea, though. Let's take the robot, let's go down 2 miles, took a sample, got a potassium-argon date of 12 million years. We said, well, that's interesting. Let's send the robot all the way down to the ocean floor, 2.6 miles down, took a sample, got a potassium-argon date of 21 million. I think I see a problem here. How about you? These methods do not work. None of them work. They all start with 5 false assumptions or 7 false assumptions, and none of them work. Well, let's go on. This is my favorite kind of fossil. Now, my favorite kind of fossil is called a polystrate fossil. Now, again, when I use a big word, I always like to explain what it means. All of you would know the word poly means many, correct? Now, straight, strat, stratum, this all refers to layers. And so a polystrate fossil is any fossil which penetrates through 2 or more layers of the fossil record. Now, they are usually tree trunks, but they're often bone. But any fossil that penetrates through 2 or more layers of the fossil record, they are usually tree trunks, but they are often bone. Now, here you see in this photograph from Australia, many, many layers. Is that correct? Everybody see the polystrate tree trunk? Well, if you can't, it's right there. But what's particularly interesting about it is this. First of all, it's not petrified, it's coalified. This is a tree trunk turned to coal, but you'll notice it has no roots and no tops. It's just a log. Is that correct? Kind of tells you it didn't grow there, doesn't it? Well, let's think about this. How did coal form anyway? I mean, how many of you remember being taught in school the old swamp theory of coal formation? They used to teach us in school back, when I was in grade school. They used to say, oh, there were forests and swamps covering the earth 360 million, suppose, years ago at the time of the Carboniferous period, that these trees grew up in these swamps and they fell over and died, and they built up in the water of the swamp. And because there's so little oxygen in the swamp water, the trees piled up one on top of the other, and that's how we got coal. Does that sound at all familiar? But nobody teaches that anymore, at least not any honest evolutionist, because they all know it's not true. You see, first of all, let's take a little look. Here you see some small coal layers or coal seams, is that correct? But first of all, think with me. Do you notice it's flat on the bottom and flat on the top, is that correct? So first of all, does anybody here see roots coming down from below these layers? No roots. It's flat on the top, flat on the bottom. Number 2, you only find natural gas, coal, and natural oil between layers of sedimentary rock. Now, what is sedimentary rock? That's layers of dried out mud, is that correct? So you only find natural gas, natural coal, natural oil between layers of dried out mud or some kind of sandstone. But there's something else here too. Notice right here. See how this coal seam forks right here? At the fork right there? Well, once they started realizing that, they started realizing the swamp theory simply wasn't true, and they stopped teaching it altogether. Now this is a pure layer of anthracite coal. Now anthracite coal is the hardest, densest, blackest, bestest coal there is. Anthracite coal is the really good stuff. Now this comes from our state of Michigan, but this is about 1.5 to 2 foot thick layer of pure anthracite coal, the really good stuff. Now let's think. To get anthracite coal, you have to have 10-foot thick layer of plant and wood deposits compressed down to 10 to 1. Okay, so it takes 10 feet of material compressed to 1 foot to get hard anthracite coal. Now, if you take 10 feet and you compress it maybe 3 to 1, you get soft coals like lignites, and 5 to 1, you know, you'll get soft coal, and maybe down 5, 7 to 1, you'll get bituminous coals and so forth. But it takes 10 to 1 compression ratio to get anthracite coal. However, in our state of Utah, we have a pure layer of anthracite coal 200 foot thick. Now that tells you there had to be a layer of logs and vegetable material 2,000 foot thick there at some time in the past to be compressed down to 200. Is that correct? I would suggest to you only a worldwide flood could do that. A layer of logs and wood 2,000 foot thick, all in one place, all at one time, would require a worldwide flood. And this is a bell found in 1944 in medium grade coal in our state of West Virginia, but the coal is supposedly 300 million years old. Oh, it's a very unique alloy and has a iron clapper on it and so forth. But this is a pre-flood bell used between creation 6,000 years ago and the flood of Noah by somebody, and trapped in the coal from the flood. And doesn't it take millions of years for fossils to form? I mean, you know, I grew up on the campus at the University of California, Berkeley. Now, I did that because my father was a student at Berkeley. He got his degrees at Berkeley. He went on to become a professor at Berkeley, at one time a secretary to the president. And I actually grew up on the campus of the University of California, Berkeley. Now, that's the bad news. Here's the good news. The good news is that when I was not in the California public school system learning evolution in elementary school, well, I was in the paleontology laboratories at the University of California, Berkeley, learning about dinosaurs, fossils, and evolutionary theory from PhDs when I was just in elementary school. I learned about this so well that by the time I hit the 3rd and 4th grade, they used to borrow me from one class to the other, and I used to teach the other children about fossils, dinosaurs, and evolutionary theory because I knew more about it than the teachers did. That's an absolutely true story. Now, they taught me back in those days at Berkeley that it takes millions and millions of years to get fossils. They told me that dinosaurs, you know, been dead for 65 to 70, up to 150 million supposed years. But I don't believe that anymore. I don't. Now here's why. They say it takes millions and millions of years for a fossil to form. Is that correct? Right? Well, let me show you a fossil. This is kind of an interesting fossil. It's called a Teddybearosaurus. Now this Teddybearosaurus fossilized, it only took 4 months. This was formed along the Thames River in England. There's a place where they have this overhang and a walkway underneath, and it's limestone rock, and there's water that comes over the limestone rock along the Thames River there, and people actually walk along underneath, and they tie tennis shoes and teddy bears and other things, Coca-Cola bottles, you know, on long strings, and they come back, and 4 months later they have a fossil. You're not impressed? Well, how about this fossil? This is a coil of man-made rope, but this fossilized in only 2 weeks. Are you impressed? Well, if you're not impressed yet, how about this? I think you'll agree, that is a fossilized fish, is that correct? But this fossil fish is quite interesting. You see, according to the evolutionists who found it, it died and was fossilized in less than 5 hours. Oh yeah, You see, this comes from Brazil. The Santana Formation was reported in 1989, but we found fossil fish with fossil gills, fossil muscles, fossil stomachs. The evolutionist paleontologist who found it did not allow his theory to get in the way of a good scientific observation. I applaud him for that. I really do. I really do. And he said this, quote, "What is clear is that the fossilization process took place moments after the fish died and was completed within only a few, probably less than 5 hours," unquote. But he went on to say this, in this case, quote, "Instantaneous fossilization," unquote, "is suspected to have been the very cause of death." Did you get that? DOA, fossil. This evolutionist paleontologist was making a valid scientific observation. I do applaud him for this. He was being honest. He didn't let his theory get in the way of his, observation. And he made a good scientific observation. What he said was, based upon what he found, the cause of death might well have been fossilization. So I guess it doesn't take millions of years to get a fossil, is that right? Oh. And then we have helium missing from the Earth's atmosphere. Helium is made in the crust of the Earth by the decay of radioactive material. It's the only way helium is basically made on Earth. Now, let's think about this. It's produced by the decay of radioactive materials like uranium in the crust of the Earth. Now, when that helium is made in the crust of the Earth by the decay of radioactive materials, it leaks out through the rock because it's an inert gas. It won't combine with anything else. It leaks out of the rock and into the atmosphere. Now, it is not lost into outer space. As a matter of fact, we actually get a slight addition of helium to the Earth's atmosphere by cosmic winds, but it's not lost into space. So whatever helium has been made on Earth is still basically here. The problem is this. Though it escapes in the atmosphere and stays here, there's only enough for the atmosphere to be less than 2 million years old. Now I would find it problematic to have an Earth that was 4.6 billion years old, but an atmosphere that was less than 2 million. How about you? And here, there's too much salt in the Dead Sea. Now here's a satellite photograph of Israel. Here's the Sea of Galilee, the Jordan River, the Dead Sea here. But the Dead Sea has too much salt in it for it to be old. The north end today is 31% salt, the south end 37% salt. This is why you can't drown in it unless you strap on about 500 pounds of lead weights. But think with me for just a moment. All this salt would actually accumulate in less than 13,000 years. But evolutionists will tell you that the Jordan River Valley, this volcanic rift valley that we have here, they will say it is anything from 5 to 10 up to 20 million years old. But think with me for just a second. If in fact the Dead Sea were, and the Jordan River Valley were 5, 10, 20 million years old, well, that means that the Jordan River flowing into the Dead Sea would have to be cleaner than distilled water for 20 million years. Anybody here ever seen the Jordan River? It's not that clean, right? So this is what we call a regional geochronometer. But it simply shows that this is not 5, 10, 20 million years old. It's less than 13,000 and totally acceptable with only 6,000 or in fact 4,500, which is from the time of Noah's flood. I'm sure you've also all noticed that the moon is moving away, right? You all had noticed the moon is moving away, right? Where are your powers of observation, people? The moon is moving away from the Earth at a staggeringly fast rate. Come on, are you all ready to be staggered? Come on, are you all ready to be staggered? Well, the moon is moving away at a staggeringly fast rate. It's moving away at 2 inches a year. Come on, 2 inches a year. Aren't you staggered? You're not? Well, you should be. Think with me for just a second. Today, you don't have to believe me. Today, you can prove this in a laptop computer, desktop computer at home or the office. The moon is moving away at 2 inches per year. Now, do any of you remember something called the law of gravity? Come on, you all do remember something called the law of gravity, right? And the law of gravity says basically that as two objects get closer together, there's a stronger and stronger pull together. Is that right? Now, it's an inverse square law. You half the distance, you quadruple the force, and so forth. But you plug the formula into a laptop computer today, and you can prove to yourself, think with me, If the moon is moving away at 2 inches per year now, well, if I go back 1 year, it would be 2 inches closer, correct? Another year would be 2 inches closer. But as the moon starts to come back towards the Earth, well, then the force of gravity starts to increase. Is that correct? And the rate at which the moon comes back gets faster and faster, correct? Now, again, as I said, you can prove this in a laptop computer. If you go back in time, the moon would come back in, spiral in, and hit the Earth 1.4 billion years ago. Now, evolutionists say that the Earth and the moon are the same age. They say they're 4.5 to 5 billion supposed years old. Most of them say 4.6 billion. But if evolutionists were telling the truth, then that would mean that the moon was attached to the Earth for the first 3.6 billion years. Is that correct? And then it has been moving away ever since. Have I got that right? Hello? Now, there's something else I want you to notice here. Did you notice the bouncing arrow? And did you notice down here, I'm going from the age of the Earth at 4.6 billion, and it's getting younger. So did everybody see that now? I want you to, okay, right, here's the bouncing arrow. And then the age of the Earth gets younger. See how, was that cool? Oh, come on, that was neat, right? Thank you. Well, you want to keep watching these bouncing arrows. You also want to keep, watching the bouncing arrows and the age of the Earth getting younger.